Hi boys and girls, today I'm going to show you Day 4 review, Operations in Algebraic Thinking and Geometry Test Prep. Let's begin. Which expression means the same as the one below? 6 times 8 is in parentheses, and then add 20. So let's look at A, B, C, and D and write what they would be. 6 times more than the sum of 8 and 20. So this one says 8 and 20 and 6 times more. So that would be 6 times the sum of 8 and 20. That doesn't look the same. B says 20 more than the product of 6 and 8. We know that product means multiplication. The product of 6 and 8. 20 more than that is 20 plus 6 times 8 first. That could be it. C says 20 times the product of 6 and 8. 6 times 8 is product again. No, doesn't look like that because there's no 20 times. And the next one says the product of 20 and the sum of 8 and 6. So that one doesn't look right either. The only one that makes sense is B, 20 more than 6 times 8. Mine looks a little different than this, but why are those the same? Well, because the 6 times 8 is done first in either problem, and the plus 20 is done at the end. So it doesn't matter which order I wrote it in and which order the problem is written in. Which problem represents the expression 27 subtract 9, then divide by 3? So let's see. It looks like they're giving us a word problem. We're going to have to figure out, we have to have 27 of something, take away 9, and then divide that answer by 3. Let's see. A says a PE teacher keeps 9 of the 27 balls he purchased. He distributes the rest among 3 teachers. He keeps 9 of the 27 he purchased. That's confusing. Let's continue and see. The PE teacher keeps 3 of the 27 balls he purchased. He distributes the rest among 9. Well, we know it's not divided by 9, so it can't be B. A PE teacher keeps 9 of the 27 balls he equally distributed among 3 teachers. Well, that doesn't make any sense because he keeps 9 of the 27 balls he equally distributed among 3 teachers. Well, what are you doing first? It doesn't really clarify. And D says a PE teacher equally distributed 27 balls among 9 teachers and kept 3. Well, that doesn't say he kept 3. So let's look at A again. He keeps 9 of the 27 balls. So he had 27 balls. He kept 9. So he took 9 out of that group. And then it said he distributes the rest or splits the rest among 3 teachers. So is that the same as our expression? Yes. Which expression means the same as the one below? Let's do some process of elimination. A says 25 increased by 11, which is correct, divided by the sum of 9 and 2. Well, the sum of 9 and 2, this is telling me that they want the sum of 9 and 2 first, which we know that they don't. They want this divided by 9 and then add 2, following our order of operations. Part B, or problem B, answer B, says the sum of 25 and 11, yes, divided by the sum of 9 and 2. Nope, I don't think so. The sum of 25 and 11 divided by 9, then increased by 2. This makes sense. They want the sum of 25 and 11 first, because that's what's in parentheses. Then we always follow multiplication or division in our order of operations before going to addition and subtraction, so C makes complete sense. And then D says 11 more than 25, which is correct, decreased by 9 plus 2. Does that mean decreased? No, that's divided by. So D also doesn't make sense. So if we were to write these out, the sum of 25 and 11 would be 25 plus 11 divided by 9, then increased by 2. So C is the correct answer. Which expression is true about the 2 expressions below? Well, let's look at them. Expression A says 56 plus 3, or the sum of 56 and 3, times 10. Expression B says 56 plus 3. So let's see what's the same. Well, 56 plus 3 in A, you have to multiply by 10 after you get the sum. So A says expression B is 10 more than the value of expression A. Is this 10 more? No, that doesn't even make sense because this isn't even 10 more either. So A does not make sense. 10 more would be plus 10. Expression A is 10 more than the value of B. Is this 10 more or plus 10 than B? No, it's times 10, so it can't be 10 more. It'd be 10 times. Expression A is 10 times the value of expression B. Yeah, this is 10 times bigger than this. And D, expression B is 10 times the value of expression A. Nope, B is not 10 times greater than A. A is 10 times greater than B. So the correct answer is C. Evaluate. Evaluate means to solve. We're going to follow PEMDAS in order to solve. Some of you may need to write this down so that you can remember. So parentheses is first, so we're going to see what we have for parentheses. Well, I have two parentheses here. So we're going to look within this first, and we're going to follow PEMDAS in this first. So we're going to follow the parentheses in here first, which is 4 plus 3. 4 plus 3 is 7. We're going to write everything else down just the way that we see it. Okay, and now we're still following parentheses just within here because we're in our parentheses. So we're done with parentheses. Do we see any exponents? Nope, no exponents. We have to multiply and divide from left to right just within this parentheses. So 7 times 2 is 14. We're going to write everything else down just the way it is. Okay, we're still working within this bracket first because we're always in parentheses first. Any more multiplication and division from left to right? Nope. Add and subtract. So 14 minus 8, 6. Now our brackets are gone. And divide by 3 is the last step. If we were going to, if we had other things here after the parentheses, or after we finish this bracket, we'd have to start up at parentheses again and work all the way back through. So we'd have to do parentheses, don't see any, exponents, don't see any, multiply and divide from left to right. 6 divided by 3 is 2. So the answer is D. And again, as you've seen, what I like to do is I like to solve the problem and then come back and look. We know the answer is not 3, 14, 12, or 12. We know that we got 2, so our answer is 2. Jolynn's math teacher drew a triangle that had a 60-degree angle and a 20-degree angle. What is the measure of the third angle in the triangle? Well, you have to have some knowledge about triangles to solve this problem. So let's just draw a triangle. Mine might not be looking exactly like a 60-degree and a 20-degree angle, but that's okay. So we know a triangle has how many angles? We have 1, 2, 3 angles. So if one of the angles is 20 degrees and one of them is 60, we have to find one more angle. Okay, you also have to know one more piece of information to solve this problem, that all 3 angles added together in a triangle equal 180 degrees. So all the angles in a triangle equal 180 degrees. So what I can do is I can subtract the angles that I know. Okay, so if I subtract the 20, I get 160, and I subtract the 60, I get 100. So I know that the last angle has to be 100 degrees because all of my angles should add up to 180. So 100 plus 60 plus 20 equals 180. It's all of the angles in this triangle. So I know that my answer is B. Lucinda plotted 4 points on the grid below. She connected them to form a geometric shape. What geometric shape is formed? Well, let's look at our shape. Our shape has 1, 2, 3, 4 sides, so we know our shape is a quadrilateral. Let's see, what else do we recognize about our shape here? Our shape has 2 sides that are parallel, so our shape is a trapezoid. What else do we notice about this shape? Well, we know that this angle is the same as this angle, and this angle is the same as this angle. They're not 90-degree angles, so that rules out a rectangle and a square. And looks like the opposite sides are not equal or congruent. So the 2 names I have for this figure are quadrilateral and trapezoid. Let's see what our suggestions are. Is it a rectangle? Well, we said it didn't have 4 right angles, so it can't be a rectangle, and opposite sides are also not equal, so it cannot be a rectangle. What makes a rhombus? Well, a rhombus has all equal sides and opposite sides that are parallel. Well, one opposite side are parallel, these aren't parallel, and the sides are not all equal, so it can't be a rhombus. A square. Well, we know a square has 90-degree angles, and we know that a square has opposite sides that are parallel and opposite sides that are equal, which this does not have any of those traits, so it can't be a square. And we did say that this was a trapezoid, so the correct answer is D, trapezoid. Which pair of triangles are congruent? Well, what does congruent mean? Congruent means equal, okay? So congruent means equal. Is triangle A that goes up 1 and over 2 the same as this one that goes up 2 and down 2? Nope, can't be that one. B looks like it goes over once and up 2. This one's over 2 and up 2. Can't be B. C looks like it goes over 3, up 2, down 1. Looks like it goes over 3, up 2, down 1. Ooh, C could be congruent even though they're flipped. And D is over 2, up 2, and this one's over 2, up 3. Can't be D. So the correct answer is C. Those triangles are congruent or equal. Fredo drew the equilateral triangle shown below. What is an equilateral triangle? Equilateral triangle means that all 3 sides are equal and all 3 angles are equal. So he drew this equilateral triangle. Which equilateral triangle is congruent to Fredo's triangle? Well, congruent means equal. So basically, if we were able to cut this triangle out, would it be equal or congruent to A, B, C, or D? Well, D's too big, and ideally, I would use a protractor and a ruler to figure this out. So if you do have a piece of paper, you should use a ruler and a protractor to figure this out. But D is too long, C is too short, and B, the sides are too short. So congruent triangle A is congruent to Fredo's triangle. Make sure on these types of problems you are using a ruler and a protractor to help prove that the triangle is congruent. Alice draws a triangle and measures 2 of the angles with a protractor. The angle measures are 65 degrees and 45 degrees. Cal says the measure of the third angle is 60 degrees. On the lines below, explain why Cal's answer is incorrect. Be sure to identify the correct measurement of the third angle in Alice's triangle in your explanation. So we talked about this in a previous question, but let's talk about it again in case you didn't listen. We know that a triangle has 3 angles, okay? We also know that all of those angles add up to 180 degrees. So if Alice's triangle measures 65 degrees, one angle, and 45 degrees, another angle, we can figure out the third angle by adding those 2 angles together and subtracting them from 180. So 65 plus 45 is 110. And if we subtract 110 from 180, we get 70 degrees. So we know that our third angle has to be 70 degrees. So in order to explain this to Cal, we may say that we have to know that all angles add up to 180 degrees. And 180 minus 45 minus 65 equals 70 degrees. So the third angle must measure 70 degrees. Sean's answer to the test question below was 10. We need to evaluate or solve this expression, and then we're going to explain if Sean's answer was correct. So let's solve and see if he's correct. We're going to follow the rules of PEMDAS, or parentheses, exponents, multiply and divide, add and subtract. Okay, so first we look within parentheses. Okay, we've got lots of parentheses here. So we're going to look in these brackets. Okay, then within there, do we see any parentheses? Yes, we see another brace. And then in there, do we see parentheses? Yes, so 2 times 3 is going to be first. 2 times 3 is 6. We're going to write everything else down just the way that it is so we don't get confused. Okay. All right, so everything else is written down just the way it is. Now, we're still looking within this bracket here. Okay, we've got to finish this bracket, and then we go outside this bracket. So we have 11 plus 7 minus 6. Do we have any exponents? No. Do we need to multiply and divide from left to right? No. So we need to add and subtract from left to right. 11 plus 7 is 18. I'm going to write everything else down just the way it is. Now, I'm continuing on with adding and subtracting from left to right within this bracket. 18 minus 6 is 12. Okay, now those brackets are gone. So now I have to follow PEMDAS again within this brace here. So parentheses, there's nothing within there. Exponents, no. Multiply and divide from left to right, no. Add and subtract from left to right. 12 plus 8 is 20. And now we write everything else down just the way it is. Our braces are now gone because we just did 12 plus 8 and got 20. Now we have to follow PEMDAS through this. Any parentheses? No. Any exponents? No. We need to multiply and divide from left to right. 20 divided by 2 is 10. So the answer is 10. So was Sean correct? Yes, Sean was correct, and we can prove that he's correct by following PEMDAS. So if you had to explain this, I would say you'd follow parentheses, exponents, multiply and divide, add and subtract in order to prove that you did this correct. You can even say first you do this, then you do this, then you do this, then you do this, to give them a step-by-step reasoning of your understanding of evaluating these types of expressions.